Welcome to Seismic Data Processing course. In the previous lecture we talked about the field data, how the seismic raw data is recorded in the field, and we end up with all the data from geophone and filter amplifier. We end up with multiplexer. In the multiplexer he will pass one set of data one after another to transfer to the ADC. So we continue today. We have the three main processing. Preprocessing, you have demultiplexer, reformatting, and trace editing. In the demultiplexer, so when the data is saved within the multiplexer, we have A, B, C, D. This is the seismic traces. So in the multiplexer, he will send the first time slice of A1, B1, C1, and D1 from the sample number 1, and then for all the traces for sample number 2, all the traces for sample number 3. So you have A3, B3, C3, D3 into A9, whatever. But however, processing software require the data to be as trace sequential. So all the data from the sample number A and then sample number B, C, and D. So the demultiplexer is the process of rearranging this data from time slice into trace sequential. So from time slice, A, B, C, D into all the A, all the B, and C, and D together. So this is what the demultiplexer mean. And then we have reformatting. Reformatting is where you reformat into a standard structural recognized by seismic processing software. So reformatting include organize the trace header and data type. And the most famous is modify SEG-Y. SEG-Y is the most widely used for processing today. So we have the trace editing. In the trace editing, we identify and remove the noise from the trace, seismic trace. First, the cause of bad traces, the dead geophones, no signal, bad geophone blunting, poor ground contact, seismograph amplifier failure, or cultural noise. We have vehicle or power line, etc. Burner surface condition. So trace editing can be manually or automatic using some software. So the purpose of trace editing to clean up the dataset and ensure only valid interpretable seismic traces are processed further. So within the trace editing, we use a method called muting, and the mute is to remove the ground rule and refraction to show us a title line, and also for air coupling wave we only care about just the reflections. Reflections is the only seismic signal that represent the true subsurface layers. So why muting is important? Muting is a process of suppressing, zeroing a part of seismic traces that contain undesired energy. So if you have undesired energy such as the direct wave or refracted waves before stacking or further processing, it's like making out the part of the data that don't present true subsurface reflections. So the muting is like any unwanted or desired waves, like for example a direct wave or refracted wave. You set the amplitude to 0 so it not have any noise effect. To remove undesired wave, this to remove the direct wave. The direct wave is the travel direct from the source to receiver through air or near surface. So you will notice the direct wave you have like horizontal line from the source to receiver. Refracted waves, this is a band along high velocity layers near the surface. These appear early in time and often with high amplitude, so they can mask or distort reflection signals. So we use the muting method to remove the direct wave and refracted waves and not affect on the reflections signals, the true reflection signals that represent the true subsurface layers. Also, to protect reflections quality, without muting, coherent refracted energy may be misinterpreted color reflections and false structurals to stacking or migration sections, cause incorrect geological interpretation. So to handle linear move out, Refracted energy usually shows linear move out, straight line on the shot gathering, while reflections is like a hyperbolic. So we can distinguish the reflections to show as a hyperbolic, while the direct wave or refracted as a linear move out. So the muting process, not just cutting the high frequency part. Apply it carefully. You have to apply it carefully. Define time windows. You have to choose where to start and stop the muting on the trace. Also define taper length. After we cut the signal, how smooth the signal will be merged with the other signals. Apply the gradual fade out taper instead of sharp cut off to avoid the frequency artifacts, to avoid the noise. Also frequency filtering, we use the filtering, and fine tune taper, adjust to balance noise removal and signal preservation. So the type of mutes, we have top mute. These are remove early time energy, direct or refracted waves. These apply to the top of the trace near zero time, most common type. So the most common type is the top mute. You mute from 0 millisecond to 100 millisecond to remove air wave or ground rule. So we have, this is the seismic gathering, the shoot gathering. The horizontal is represent the distance from the source to geophone, the channels, and we have the time. So from 0 to 100 millisecond, 0 to 100, these represent the surface, ground rule and direct wave. So the top mute to mute all the data above this line and to cut this part. We have bottom mute to remove unwanted energy after reflections, often used to cut off noise later arrivals, usually in marine data or noisy land records. Example, you mute everything after 2.5 seconds where only noise exists. So 2.5 seconds for if you have a noise in here is called the bottom mute. This bottom mute to cut any data below this line and remove this from the seismic signal. We have surgical mute. This target specific linear noise patterns seen on the shot gathering, like reflections or multipliers. Applied only along selected time offset path. You can visually draw a mute polygon following the refracted events as shown in the image. So for the surgical mute, so the red curved lines represent the surgical mute. It represents like a polygon. So we need to remove this one. And also we have single trace culling used to entirely remove zero out an individual noise or dead trace. So we will apply all these mute type within the software. So next step, I will let you download the software, the processing seismic data software, and we will use this software to apply how we can remove and how can we mute our seismic signals one by one and learn the four type of muting. So thank you for watching and see you in the next video.